Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 11 from the May-June 2022 Pure Mathematics paper from Cambridge 9709. This is paper 1, variant 3. And this question here is the last question of the paper. And in general, I would advise against doing the last question on the paper first. Some students, for some reason decide to try and do that. The last question on the paper normally requires a bit more thought and insight, and sometimes it takes time, and many times students are not able to finish it on time. And if you were to spend the beginning of the exam trying to think about it, you might get the answer in the end, but then you will have lost a lot of time that you could have got marks from the earlier question. So never do the last question in the paper first. The last question normally has a bit more to it, a bit more meat to it, a bit more thinking involved, and it's possible that we're not able to finish the last question. But don't sacrifice the other questions. Like the first few questions normally are the simpler questions, and don't sacrifice those marks for the few marks you might get extra if you spent longer on this question. Okay, so don't ever do that. That's one thing. Now, this question here, the point P lies on the line with the equation y equals mx plus c, where m and c are positive constants. So this is a straight line and has a gradient going this way, and it passes through the y-axis somewhere above the x-axis, somewhere in the positive part, because c is positive and m is positive. So positive gradient means it slopes upwards, and positive c means it cuts the y-axis somewhere up there. So that's what we can tell from that bit of information about the straight line, y equals mx plus c. A curve has equation y equals negative m over x. Okay, again, the same m as this, but the m here is positive. So negative 1 over x or m over x will have the same shape as, like this is what you'd have as 1 over x, or a positive number over x. If it's a negative number of x, which this is going to be because m is positive, so the whole thing is going to be negative, it's going to be something in these two quadrants. It's going to be a reciprocal curve in those two quadrants, so it's going to look something like this. Okay, so there will be y equals minus m over x. Okay, so it's going to have this type of shape. It's going to have asymptotes. The x and y axis are going to be the asymptotes. We'll never touch them, and it will go something like this. Right, that's how that would look. All right, so we just got an idea of picturing what we're doing is always a good idea, right? There is a single point M on the curve such that the straight line is a tangent to the curve at P. Okay, so there's a point somewhere on this curve where the line is a tangent to this curve. All right, now, where could this line possibly be? Where could this point possibly be? Well, it can't be on this side of the curve, because if it was on this side of the curve, then C would be negative. The y-intercept will be negative. Okay, so it must be somewhere. I'm trying to move this. Okay, it must be somewhere on this side. The tangent, it must be a tangent on this side to the curve. So P must be a point somewhere over here, such that the y-intercept is going to be a positive value. C is positive. So we know that there are a couple of places where the gradient of the curve and the line will be the same. One of them would be this point here, P, and another point would be somewhere down here, which we don't know. Okay, we haven't been told about that. So basically, that's what we've kind of like got the idea of in the question so far. We've kind of pictured what's going on. It's always a good idea to picture what's going on, even if you've got things in terms of letters instead of numbers. We can see that their m and c are positive constants, so we can work out basically what's happening. All right. So now it says find the coordinates of P, giving the y coordinates in terms of m. Now, there are two methods that you could use to find the coordinates of P. One method is to use the fact that the tangent meets the curve at one place. The tangent, okay, intersects, or you could say meets the curve. It doesn't really intersect, it touches it. Meets the curve at one point. Okay, there's one intersection. You could say there's one root when you try to solve the equation of the curve and the tangent. Okay, so the tangent is y equals mx plus c, and the curve is y equals minus m over x. So if I solve these two equations simultaneously, there's going to be just one real solution. Okay, or one, you can say, repeated root, one repeated solution. Okay, so when I solve these two equations simultaneously, I should get one repeated root. Okay, so as we know, solving equations simultaneously involves replacing or substituting one equation to the other. So I know that y equals mx plus c. I can replace the y here with mx plus c. Okay, so that's what I'm going to do. So I'm going to say mx plus c is equal to minus m over x. Okay, so that's one thing. Now, to solve this, I'm going to get rid of the fraction, multiply both sides by x. So I'll have mx squared plus cx equals negative m. So I'm left with this quadratic equation, mx squared plus cx plus m equals 0. Okay, mx squared plus cx plus m equals 0. This is a quadratic equation. Okay, m and c are positive constants. So it's like a number x squared plus another number x plus another number. So we know that this equation has one root. So we know that the discriminant is b squared minus 4ac. And as I've discussed in quite a few other videos already, and you can go and look at any video that says discriminant, do a search and you'll find one. In fact, I'll put a link up here to a question where I explain this in more detail. But we know when there's one root, the discriminant, b squared minus 4ac, has to equal 0. Okay, and I explained why in the other video. It's a part of the quadratic formula under the square root sign. If this is 0, there will only be one solution. If this is positive, there will be two solutions. If it's negative, there will be no solutions. Here we want one solution because we want the line to intersect it in one place alone. So now, in this question, our a from our formula here is the coefficient of x squared, which is m. Our b in our formula is c in our letters. And our c is also m. Ax squared plus bx plus c. Ax squared plus bx plus c. So don't get confused by the fact that there's a c here and there's a c there. No. This c is a coefficient of x, so it's a b in that formula. So we can say b squared minus 4ac has to equal 0. So b is c, so c squared minus 4 times a. A is m times another m equals 0. So we're left with c squared minus 4m squared equals 0. C squared minus 4m squared equals 0. So we can say c squared equals 4m. So c is plus or minus 4m squared, plus or minus 2m. Now we know that c is a positive constant. C is positive. Okay, and m is also positive. So if m is positive and c is positive, then that means c must equal to m. Because if m was positive and you left it as minus 2, c would be negative. So c is equal to 2m. So we know the value of c. All right, that's not our answer here. We have to remember the coordinates of p. But what's going to help us now is we know that c is equal to 2m. So I can take the equation. If I solve this equation, I will find the point where P is, basically. That tells us where they intersect. But now I know I can replace C with 2M. So I have mx squared plus 2mx plus m. Why? Because C is equal to 2M. So the C took the place, the 2M took the place of this C. Okay, so 2M went into there. So you end up with mx squared plus 2m plus m. Let me just write it a bit more clearer. So we know that our equation is mx squared plus cm, plus cx, plus cx plus m equals 0. So we replace the c with 2m. That's all. So now we have an equation here, which we can see that m is a constant. So it's like you have a common factor of m. So if we divide the whole of the equation by m, like for example, if it said 2x squared plus 4x plus 2, we could divide by 2 to get rid of the common factor. So m is just a constant. It's not a variable, or it's a number that we need to find maybe eventually. So in the end here, we can just write this as x squared plus 2x plus 1 equals 0. Solving this equation will give me my value of x. Now this is a perfect square. As you can see, if you try to factorize, you'll have x plus 1. squared. It'll be x plus 1 times x plus 1. Two numbers multiply to give you 1 and add to give you 2, 1 and 1. So we see we have x equals minus 1 twice. Okay, so x equals minus 1 is the x coordinate of p. So x coordinate of p is negative 1. And we know to find the y coordinate, and we have to give the y coordinates in terms of m. We know y equals minus m over x. So we can use that. We say y equals minus m over x. We know x is minus 1, so y equals minus m over minus 1, so y is equal to positive m. So the coordinates of p, therefore, will be negative 1 for x, and it's going to be positive m for y. So that is the coordinates of the point P, and we have solved the problem. Okay, now there is also an alternative method of solving this question. Okay, here we've done it using the discriminant. We can also use another method, which I'm going to show you. Okay, so I just made a bit more space by getting rid of all that writing and showing you the next method. So this is alternative method, okay, which we can use to get the same answer, and hopefully it will work out. So again, making that sketch, I should have not actually got rid of it, doesn't matter. Making that sketch will really help us to picture what's happening. So we have something like this. As we mentioned, that we have a straight line that goes something like this, which was a tangent to the curve. And we have the curve, which is in these two quadrants, which was it's a bit thick, 1 second, which was a reciprocal curve. So it has this type of, this shape here, hyperbola shape. But I should have drawn that first. Let me draw that first. I'll forget the line, just draw this. You have something like this, and like this. And we found that the line was a tangent to the curve at a certain point. We don't know exactly what it is, but it's minus 1 and the point here is something that we worked out eventually. We don't know this at the moment, so ignore that. All right, so that's the point P, okay, where the tangent with this line y equals mx plus c is a tangent to the curve y equals minus m over x. Okay, so we need to find the coordinates of the point P. Now, the alternative method we can use here is that we know that at P, the gradient, okay, of y equals mx plus c is the same as of y equals minus m over x. They share the same gradient. And we can say that the gradient of the tangent is equal to m. It's actually m. This is the gradient because y equals mx plus c. This is the gradient of the straight line. So therefore, the gradient of at P, okay, the gradient of the curve is equal to m. Okay, so what we can do here is we can find dy dx for the curve. So we know y is equal to minus m times x to the power of minus 1. I've written it in this form, okay, minus m over x minus m x to the power of minus 1, so that we can differentiate it. When you differentiate, you multiply by the power, so you get m x to the power of minus 2. So we can say dy dx, the gradient function for the curve, is m over x squared. And we know, what we know is that at P, okay, dy dx is equal to m. So we can say m over x squared is equal to m. So therefore, if you rearrange this, you have m over m equals x squared. So x squared equals 1. So x can be either positive or negative 1. Take the square root of it. However, we know p, okay, must be on this side here, as we discussed earlier. Okay, p must be on this side. If p was on this side, if the coordinates of p was negative 1 over here, then the straight line that we have, the value of c would be a negative value. The value of c would be a negative value. Okay, because this will definitely go through y, the y-axis at negative value. So we know, okay, p must have, okay, a positive x coordinate. It must be positive, okay, for it to be able, for y equals c to be a positive value. This is c, it has to be positive. All right, so x must be equal to minus 1. So therefore p must have a negative x coordinate. sorry about that, must have a negative x coordinate. A negative x coordinate. So therefore we can say that x must equal -1, and therefore we know that y is equal to minus m over x. So therefore y is equal to minus m over -1, which is positive m. So we can say P has coordinates -1 and m. So this is actually a bit of a shorter way of doing it. Okay, given the y coordinates in terms of m, that's fine. So there we have the answer by using the fact that the gradient of the tangent is the same as the gradient of the curve at that point. So we find the gradient of the tangent, okay, which we know from the curve, from the equation of the line. We find the gradient function for the curve and you equate it to the equation of the tangent, and then you find the value of x and then the value of y. Okay, so that's part A done in two different ways. Okay, so the first way is using the discriminant about the intersections, and the other way is using the fact that the gradients are the same. So that's 11a. Now for 11b, it says the normal to the curve intersects the curve again at the point Q. Now remember the equation of the tangent was y equals mx plus c. The equation of the curve itself was y equals minus m over x. Okay, the point P was -1 and m. Okay, so those were the pieces of information we got. Now, it tells us that the normal to the curve, so I'll just make a quick sketch again. We've got the curve that looks something like this. And you have this side as well. At -1, you have a tangent to the curve going something like this. Okay, so the tangent goes something like this. Touches the curve at -1. It doesn't pass through it. That's -1 and m. That's a point P. Okay. Then it says the normal to the curve intersects the curve again at the point Q. So the normal to the curve is basically a straight line which is passing through the same point as the tangent but perpendicular to it. So the normal to the curve will be something like this. This would be, I haven't drawn it that quite 90 degrees. You don't have to draw it accurately, but that will just help you to visualize. Okay, so that's the normal. The normal, this is the tangent, which has the equation y equals mx plus c, and this is the normal to the curve, right? So it's at 90 degrees to the tangent. Now it passes again the curve at the point Q. Okay, so we have to find what the coordinates of Q are in terms of m. All right, so in order to do that, I need to know where does the normal intersect this curve. So I need to find the equation of the normal. If I find the equation of the normal, I can then find where it intersects this curve. I know one point, there'll be another point that we can find. We know one of the points will be x equals -1. We need to find the other point. So the equation of the normal can be found by the fact that we know that it passes through the point, which we have, -1m, and we need to have the gradient of the normal. Now the gradient of the normal is the negative reciprocal of the gradient of the tangent. And we can see that the gradient of the tangent is equal to m. So the gradient of the normal is -1 over m. So with that information, we can find the equation of the normal. And I like to use this equation, y minus y1 equals m times x minus x1. Now be very careful here because they've got gradients in terms of m and stuff like that, and even y coordinates in terms of m. So be careful here. Our point x1 is -1. Our point y1 is m. Okay, our gradient is -1 over m. Those are the values you're going to put in here. So you have y minus y1, which is m, equals m times, which is -1 over m, times x minus x1, which is x minus -1, x plus 1. Okay, now I can find the equation of this line. So I'll have y equals -1 over m x minus 1 over m plus m. That's the equation of the normal. That's the equation of the normal to the curve. Okay. Now we want to find where does this intersect with the curve. So we have to solve the equation of the simultaneous equation minus m over x with the equation of the normal. So we have to basically, I'm going to replace, let's see which way I'll do it this time. I'm going to replace this y and replace this y with minus m over x. Okay, so right now I can't see how it's going to pan out, but we're just going with the flow as we know, as if these were normal numbers. The thing that's a bit confusing for a lot of students in this type of question is because you have these letters that represent these constants and they start to get like all lost. But we're just following the same format as we would, as if we're trying to find where this line intersects this curve. We're doing exactly the same things. Don't worry about the fact that we have letters and numbers which are letters representing these numbers. Don't worry, just do the same thing that you would normally do. So I'm going to replace the y with minus m over x, and I've got this is minus 1 over m x minus 1 over m plus m. Now, what I'm going to do here is I'm going to just get rid of the fractions. I'm going to multiply everything by x times m on both sides of the equation. Okay, that will get rid of the fraction. So if I multiply this by m times x, I'm going to end up with minus mx. Minus m squared x, sorry. Minus m squared x. Because I'll have the x cancel out, you're left with m times minus m squared. The x's cancel out. Okay, if I multiply this term by x times m, okay, then the m's will cancel out. I'm left with minus x times x, which is minus x squared. Okay, the m's will cancel out. You'll be left with x times x, so minus x squared. If I multiply minus 1 over m by this, I'm going to end up with just the m's cancelling out, leaving me with minus x. And here I'll have m times x times m, which is going to be plus m squared times x. Okay, so now I have what looks like a quadratic type of equation. Okay, let me just leave that as it is. So what I'll do is I will gather together the x squared terms. I've gathered together everything on this side of the equation. So I'll have x squared minus m squared, just x squared, sorry. There's no other x squared term, right? So it's just x squared, and then you're going to have minus x. So this whole thing will become plus x minus m squared x. Just adding x to both sides, taking away m squared from both sides. And I've got minus m squared equals 0. Right? So this is a quadratic equation. You can think of it as x squared plus, and this would be 1 minus m squared times x minus m squared equals 0. You can think of it like this. This is x squared, this is a constant times x, this is a constant. So we're going to try to solve this. Now, it might seem a bit odd to try to solve this by factorizing, but that's what I'm going to do at first. And if it works, fine. If it doesn't work, we can use a quadratic formula. This is a is 1, b is minus 1m squared, and c is minus m squared. We could try to use a quadratic formula. We need to solve this equation to find the value of x, okay, for which this will be, this equation will be true. So what I'm going to do is I'm going to resort to my strange window method. And how does this work in this kind of situation? Well, I'll show you, because what we have here, we could do this by splitting the middle term. I'll show you that way as well. It's the same thing basically, but we have here, it's like the middle term has been split into two parts, you could say. You have x squared plus something x minus m, the constant. So that this is like the middle term being split up into two parts. So let's see if this works. So for the window method, I'll write the first term over here, the last term over there, minus m squared. I want to find two numbers multiplied to give you x squared times minus m squared. And when I add them, I'm going to get x squared minus m squared x. So when I add them, I'm going to get the same as this, basically. So two numbers multiplied, the product is going to be these two multiplied, which is minus m squared x squared, and the sum is going to be the same as the middle term, which is plus x minus m squared x. And it is basically the same two numbers as this. When I multiply these together, I get this. When I add these together, I get this, of course. So I can write one of the terms in here. So I'll put plus x here. I'll put minus m squared x there. And now I can take out common factors. So I can say, for example, from these two terms, the common factor is x. X times something gives me x squared, that's an x. X times something gives me plus 1, that's a 1. X times something gives me minus m squared, that's minus m squared. So this factorizes to x minus m squared times x plus 1 equals 0. Let's check. X squared plus x minus m squared x minus m squared. That's correct. Now, I could have also done this in an alternative way, which would be probably what most of you would do, but I like to use my window, but no problem. Let's say, I'll just show you how we can do it by splitting the middle term. Basically, we factorize by grouping. There's 4 terms. X is common here, so you have x times x plus 1. Then you got minus, what's common is m squared. And in the bracket, m squared times x gives you minus m squared times x gives you minus m squared. And minus m squared times minus times plus 1 gives you minus m squared. So it has to be plus here, so that gives you that. And then we have a common factor of x plus 1 in both of these two terms. This is common in this term and this term. So that's our common factor. So we can say you have x plus 1 times x minus m squared equals 0. So we've got to that same stage here. So the next step would be either x minus m squared equals 0 or x plus 1 equals 0. Now this is the place where we know their normal intersects the curve already. We already know that point. Okay, this is the x coordinate of P, which we already know. So therefore, this must be the x coordinate of Q. The x coordinate of Q must be m squared. So we've got now the x coordinate of Q. So Q has got the x coordinate of m squared. And then to find the y coordinate of Q, we just use the equation minus m over k. Minus m over x. That was the equation of the curve. Okay, let's just make sure I didn't memorize that wrong. Minus m over x. So we can say when x is equal to m squared, y q is going to be minus m over m squared, which is minus 1 over m. So the y coordinate of q is negative 1 over m. So that's the coordinates of q. You're going to have x equals m squared and y equals minus 1 over m. And the x coordinate has to be positive. That's m squared. That's going to be positive coordinate because m is positive anyway. And the q is going to be a negative coordinate, negative 1 over m. As we can see, that's negative. So it works out just right. The x coordinate is positive and the y coordinate is negative. And we don't use this solution. This is the solution actually for where the original place we found where the tangent is. Okay, so that's the answer to this question. It's a bit of a tough one, okay, but if the numbers were not in terms of m's and c's and whatever, then it would be quite a straightforward question, which most of you should be able to do without any problem. The only difference now is they've given the numbers in terms of letters, the constants in terms of m's and c's, and that's what makes it a bit more challenging. And this factorizing bit at the end is a bit challenging. But, it just involves a bit of manipulation. When you end up with something like this, you should think, oh, there's 4 terms. I can use factorizing by grouping like I showed you here. Or you could use this method, whichever you prefer, it's fine. But you should have these techniques of factorizing. And that's one of the advantages of not just relying on your calculator for everything, thinking I don't need to know how to factorize. I just use my calculator for everything. You can't do anything with this calculator. All right, so please make sure you do have that skill. It's important to have the skill of factorizing. And don't just take shortcuts. So there's the answer to this question. It was a long question. That's why it's one of the last questions, the last question of the paper. I'm sure that not many students actually got time to finish it or, attempted some of it. But, this is what differentiates the A star eventually from the others. Anyway, so that's enough for this question. Other questions from this paper can be found in the playlist that will appear in this region of the screen at the end of the video. Other questions from this topic, which is, I guess, what would it be under? I think it'd be under quadratics, right? I'll just put it under the quadratics section because that's where this kind of question comes into. And you can subscribe to my channel by clicking on this link, and you can watch a video here which tells you how to use my channel to find what you're looking for. Thank you for watching and see you soon.